Hey everyone, welcome back to Code Streak Daily. Today we are solving a great problem, and the problem name is smallest range covering elements from K list, and it's a hard problem in Leetcode. Okay, so in this video I'll walk you through the code snippet and explain it step by step how to solve the problem and show how we can do that using a technique using the data structure. Okay. So let me read out the description here. You have k lists of sorted integers in non-decreasing order. Find the smallest range that includes at least one from each of the k lists. Okay, we define the range AB is smaller than range CD if B minus A less than D minus C or A less than C if B minus A equals D minus C. Okay, we have a condition. We have to check the range AB is less than CD. If this condition is true, B minus A less than D minus C, or A less than C if this condition is true, B minus A equals D minus C. So let's see the example here. We have an array um, 4, 10, 15, 24, 26 and 0, 9, 12, 20 and 5, 8, 22, 30. Okay, the output is 20 and 24. Okay, now in the list one, it's actually a list of lists. So in the list one, we have the elements 4, 10, 15, 24, 26. 24 is in the range 20 and 24. Okay, list 2, we have the elements 0, 9, 12, 20. 20 is in the range of 20 and 24. In list 3, we have 5, 8, 22, 30. 22 is in the range 20 and 24. Okay, so this is how we are doing this. Now the smallest range here, it is covering one number is 20 and 24. Okay, so we need to find the smallest range AB that includes at least one number from each list. If there are multiple ranges with same size, we should return the one where A is the smallest. Okay, so coming to the implementation part, um, I'll begin by importing the Python's heap queue model. We'll be using a min-heap, which helps in efficiently finding the smallest element across the multiple list. The heap queue model provides an easy way to manage the heap data structure. As I said that we are going to use a data structure technique. So I'm using heap queue. I'm taking import heap queue. Okay. Now we have to initialize the min heap as well as the maximum value. Okay, first we'll initialize an empty list called heap that will store the first element from each list. Okay, before that we have the class solution and there's a function here smallest range, and it is a list of lists which contains only integers, and we are going to return a list of integers. Okay, so I'm going to initialize an empty list with name heap to store the first elements from each list. Okay, alongside we are going to initialize another variable called max value, where I am going to initialize that to the minus infinity. Okay, I'm going to initialize that to the minus infinity. Oh, sorry, this variable will keep track of the maximum value in our current window. The range will be defined by the smallest element from the heap and this max value. Okay, now we have the second step. We have to add the first element from each list to the heap. That means we are going to push the first element of each list into the heap. Okay, for that I'm gonna take a for loop. So I'm taking a for loop here for I in range of length of nums. Okay, length of nums. Mm, now I'm gonna push that, right? Heap q dot heap push, where I'm pushing it into. I'm pushing into the heap list. How I'm pushing nums of I as well as 0. Okay, nums of I 0 and comma I comma 0. Okay, so basically here I'm taking the value, list index, and as well as the element index. Okay, and then again max underscore value will be maximum value of max value and nums of I and 0. So it's gonna compare that and it's gonna tell. So I'll tell you what we have done here. In this loop, we'll iterate through each of the case sorted list. For each list, we push a tuple into the heap. The tuple contains nums of I and 0, the first element from the current list, where I will be the index of the current list and 0 will be the index of the current element within the list. Since we are starting with the first element, then we'll update the max value to keep track of the largest value from the first elements of all the lists. At this point, the heap contains the smallest element from each list, and the variable max holds the large value. Okay, now we are gonna initialize the minimum range. So for that, I'm taking a variable called minimum range, where I'm initializing it to the negative value minus float infinity and positive value. Okay, I'm just initializing it from the negative infinity to positive infinity. Okay, so this is just a starting point. As we process the list, we'll try to update this min range to be as small as possible. Okay, now we have to loop again to find the smallest range. So for that, I'm gonna use a while loop where I'm taking while heap. So until all the elements are looped, while heap where I'm taking min value and list index and element index. I'm taking these three variables and I'm initializing these three variables to the element that I'm gonna pop, right? Heap pop of heap. Okay. Now we entered the main loop where we will continuously process elements from the heap. We'll pop the smallest element from the heap, which is stored in the min value. We also capture the list index and element index associated with this smallest element. Since we are using a min heap, the element we pop will always be the smallest in the current window of the list. See, as you can see here, here we are taking the three variables or the three elements to push into the heap, and here we are popping three elements, right? So here we are taking the minimum value as well as the list index as well as the element index. So we are popping all those, right? Now we have to update the minimum range. If the current range is smaller than the previous range, then we are going to update that. Okay, so for that I'm taking a condition max value if max value minus min value is less than min range of 1 minus min range of 0. So in that case what we have to do, we have to update the min range value, right? Min range equals to min value and max value. Okay, so at each iteration we check if the current range min value and max value is smaller than our current min range or not. We calculate the size of the range by taking the difference between the max value and min value. If this is smaller than the size of the min range, we'll update the min range to be the current range. Okay, now in the next step we are going to push the next element from the same list. Okay, we are going to move to the next element in the current list, and if element underscore index plus 1 it is less than length of nums of list index, in that case what we are gonna do, we are gonna take a new variable next value, where next value will be equals to nums of list index as well as element index plus 1. Okay, and now we are gonna do a heap push operation. Okay, we have to do the heap push operation. So heap q dot heap push, where you are pushing into the heap, what you are pushing, next underscore value, as well as list index and element index. Okay, and we are updating the max underscore value equals to max of max value and next value. Okay, if that condition is failing, we're gonna take a break, and this means that we have reached the end of the list. Okay, now we move to the next element in the list, which we pop the smallest element. We check if there is a next element in the current list or not. If so, we push the next element into the heap and update the max value if the next element is larger than the current max value. Okay, if there is no next element, that means we have exhausted one of the list. At that point, we break out of the loop since we cannot form a valid range that includes elements from every list. Okay, now we have to return the min range. Okay, now we have to return the min range. So finally, after the loop is completed, we will return the min range and the result, and this range will be the smallest range that includes at least one element from each of the k sorted lists. Okay, now let me run the code and check if all the test cases are being passed or not. Okay, we have an error. Oops, give me a second. I'll see where I have done. Okay, I need to assign that, right? Okay, what here he push expected two arguments but got four. Okay, one, two, three, four. Okay, I'm sorry guys, I missed a bracket here. Let me put a bracket here and also in here. And let me run the code and check if this is working or not. Let's see if that works or not. Okay, the test cases are perfectly resolved. And let me submit the code and check if all the test cases are being passed or not. Okay, our code is accepted and we have a runtime of 182 milliseconds, and you see it beats 88.73% of users. Okay, that's a great number actually. So we have done today's problem, and we find the smallest range that includes at least one number from each list. This solution efficiently handles the problem using a min heap in data structures. So the time complexity basically it takes is the order of n log k. uh, I hope this explanation helped you to understand the process. If it did, make sure to like this video and do subscribe the channel and hit the notification bell so you don't miss out any more coding problems, and do keep streaking guys.